Hi everyone, in this video I'm going to explain how we get characteristics of exponential functions from equations, and we can use those same equations to give us the graphs of those exponential functions. But first I want to just highlight some important things. The first thing I want you to look at is last time we talked about the basic exponential equation, f of x equals b to the x power. B is the base, x is the exponent, and the horizontal asymptote was always y equals 0. Well, this time we're going to add a little more to it. If you look at the next formula, this is the one that is really important. Okay. In this formula, you not only have b and an x, you also have a, an h, and a k. So let's look here. It says if a is the vertical shift, if a is positive, the graph is going to rise, and if a is negative, the graph is going to fall. So what that means is that if we have a graph that rises, it means it's going to go from left to right and be on the positive side of our asymptote, or on the top of our asymptote. So if it rises, it can either look like this, or it can look like this for rise. And for fall, it can either look like this or this. All right? So you see how the arrows are pointing up and arrows are pointing down? That's our rise and fall. So if A is positive, it's up, and if it's negative, it's fall. Also, in your equation, if you don't see a number in front of the equation, A is automatically going to be 0. I'm sorry, 1. A is automatically going to be 1. Whenever you see that, if there is no A in front, A will be 1. Right? The next thing is the base. We talked about the base yesterday. B is the base. It tells us if we have growth or decay. Remember, if you have growth when the B value is greater than 1, that's when you have growth. And if it's between 0 and 1, that's when you have decay. All right. Next part. H and K. This is kind of like how it is in vertex form. We did that briefly when we were in our quadratics unit. So when we're talking about vertex form, H, all right? The value of H is always the opposite of what's in the problem. So if you had something like x minus 2 in the exponent, the H value here wouldn't be negative 2. It's actually going to be positive 2. Or if you had x plus 3, the value of h is going to be negative 3. So it's always the opposite of what is actually in the equation. And when you're describing the relationship and what the graph did, if h is positive, the graph moves to the right. If it's negative, the graph moves down to the left. Right? So positive h moves it to the right, negative h moves it to the left. Lastly, you have the k value. K is real simple. K is at the end of your exponential equation. K stays the same. So if you had like plus 3, the k value would be 3. If you had minus 6, the k value would be negative 6. All right. So you don't have to switch k. You only have to switch h. So when you're doing these and you're just identifying A, B, H, and K, when you're working through to determine what transformations this exponential function did. Last thing, the horizontal asymptote is going to always be y equals k. All right. So let's do a couple problems with these rules. So the first one here, we got f of x equals 3 to the x minus 2. So we got to identify A, B, H, K. So we know 3 is the B because it has the exponent on it. So if there's no number present that we see, we know the A value is 1. And because the A value is positive 1, the graph is going to rise. Positive A, the graph rises. B is 3 because that's here on with our exponent. So B is 3. So because B is 3, we know we have growth. Next, H. Remember, H is the number that's up here with X. It's minus 2 in the problem, but remember, it's always the opposite. So instead of minus 2, it's going to be positive 2. All right. And then lastly, we have K. Well, do we have a number in the back here for K? No. So that means K is 0. And if K is 0, that means that our asymptote is going to be the line y equals 0. Okay? So that's all we're doing here. We're just describing what happens. All right. Let's do another one. On the next problem, we got g of x equals 1/2 x minus 4. So same deal. We got to get a, b, h, and k. Once again, we don't have a number in front of the term with the exponent on it, so a is going to be 1. And because it's positive 1, the graph is going to rise. B is 1/2. Remember, if you have a fraction between 0 and 1, you're going to have decay, so B is decay. H, we're looking for that. There's nothing up here with x, so H is 0. So our graph doesn't move left or right. And then K is going to be -4, so that means our graph moved down 4. And our asymptote is here at y equals -4. Real quick, I forgot to say in the previous example, when you have H was positive 2, so that means our graph moved to the right. Forgot about that. All right, I'm going to erase. And we'll do a couple more, then let you do some by yourself. All right. Last one that we're going to do, we'll do number 4, and we'll do 3 and 4. Okay, I'll do 3 and 4. So number 3, we got to get A, B, H, and K. All right. A, oh, look, we have a number in the front this time. So A is going to be positive 3. A is positive 3, so it's going to rise. B is 2. So we have growth. H, once again, there's nothing up there with the X, so H is 0, so it doesn't move left or right. And K is a number in the back, positive 1, so it's going to go up 1 unit. Our asymptote is the line y equals 1. And lastly, number 4, we got to get A, B, H, and K. So look on this one. You have a negative number in front. B can never be negative, right? And there's no number in front, so that means we have 1. But because we have a negative sign in front, A is going to be -1. So that means instead of rise, we're going to have a fall. The graph is going to fall. B is going to be positive 5, because remember, B can never be negative, so that's growth. And lastly, we have H up here. We have X plus 2. And remember, H is always the opposite of what's there. So instead of plus 2, it's going to be -2, -2. So that means the graph moved to the left 2 times. And there is no K. So K is 0. So our asymptote is the line y equals 0. Okay. Last thing we're going to do, I want you to try 4, 5, and 6 by yourself. Last one is this graph down here at the bottom. We're going to get the equation for this graph on this next example. So we'll look down here. We have this graph. We know the parent function is 2 to the x. We're looking over here and saying, okay, well, what did the graph do? The new function g to the x is what we're trying to write. Well, if we follow g to the x, f of x is here. G to the x went over and it went up. Well, it went to the right 3 times and it went up 2 times. So think about it. Well, what moves things left or right? Well, we have a, b, x minus h plus k. H moves things to the left or right, and k moves things up or down. Well, H moves things left or right. Well, this one went to the right. So if it goes to the right, remember we do the opposite. So instead of positive 3, we're going to put minus 3 up here. And it also went up 2. So we're going to go up 2 for k, because k tells us up or down, so plus 2. So the equation of our line is g of x equals 2 to the x minus 3 plus 2. Right? So on the back side of this page is your just practicing graphing using Desmos. Please be careful when you're entering things in on Desmos, because if you have more than one thing in the exponent, then you have to put it in parentheses. So for example, your first example on the back, or your first question on the back is, I believe on number 8, is y equals 3 to the x minus 2. When you put that in Desmos, you have to do y equals 3 parentheses x minus 2 to get the correct graph. Okay? That's it for this video. I will see you all in class very soon.